All right, so back to the grind. We are almost there. We can do this. Today, we're going to be taking notes on one last thing to get us set up for some experiments and demonstrations after the break. So, we want to do some of this note taking stuff early. So, today, we're going to be doing what is page 22. Page 22 is all about the word medium. Make sure it goes behind page 21 when you're done. You know the drill. So page 21 was when we started talking about the frequency and amplitude. And we did some hand gestures. We said some things that we even used ridiculous voices to help us do this. We wanted to remind ourselves that a high amplitude is a loud sound, and a low amplitude is a quiet. And a high frequency is a high pitch. The low frequency is a low pitch. And if you did it, and if you say it right, and you do the hand gestures, you'll learn it a lot faster. I wouldn't suggest practicing it right now because you have headphones on and the people around you will probably think you're insane. But make sure that you do remember all the stuff we talked about. Anyways, today we're going to be talking about the medium. Now, the definition of medium is whatever the wave is vibrating as it passes through. So the medium is what is getting vibrated by the wave. For example, when you drop something into the water and you make waves in water, the wave is going through the water. The medium is the water. When you're saying hello to someone and you are waving your hand is going back and forth. The medium is your hand. If I made a noise in the room, think about what the sound has to go through to get to your ears. Right now, it's playing in the little speakers and the headphones, and it has to travel through a little bit of air to get to your ears. So the medium there is air. The medium is just whatever a wave is going through. For instance, an earthquake. What is the medium for an earthquake wave? Yeah, it's the ground. It's the ground. Earthquake waves vibrate the ground, so the medium is the ground. All right. So today we might also mention the words conductors and insulators. Now, if you want to go back to page, I'm not seeing it. Conductors and insulators, I believe, was like page 11 of our notes in heat transfer, but it might be around there somewhere. Conductors are whatever lets the energy pass through super easily. So these might be conductors of heat, aluminum, steel, gold. These let heat pass through real easily. But things like wood and plastic and rubber, they don't. They're insulators. They slow down or stop energy from passing through. So if there are conductors and insulators for heat, are there materials that are conductors and insulators for sound waves? Well, if you think about it, there are. And there's something we can see when we measure stuff. Sound moves fast. Sound moves very fast. A sound wave that's going through air right now is going over 1,000 feet each second. Now, 1,000 feet per second is pretty dang fast. If I put a sound wave in water, it's going to be going over 4 times faster. Instead of going 1,000 feet per second, sound waves in water travel almost 5,000 feet per second. And that sounds great, but if you put a sound wave directly into a piece of wood, that wood will carry the sound wave. In 1 second, it'll carry it over 12,000 feet. Now, if you ever get to this and you're like, what does all this mean? You could go to Google and look up the change between feet per second and miles per hour. So let's take a look at it. 1,129. 1,129. Wow. So sound waves travel at 769.77 miles per hour, almost 800 miles per hour. But a sound wave in water, 4,794 feet per second. 4,794. Yo, that's over 3,000 miles an hour. So if you want to take a guess, you could look up how fast it's traveling through that piece of wood, but I can guarantee you sound waves are fast. But you notice that one of these is better than the other three. Which one is better than the other three? If you need to pause for a second so you can write it down, you can. So to me, wood seems to be the obvious choice for sound wave. It's carrying it a lot further, a lot faster. So why? Which state of matter is the best for this? If you look at the states of matter, if you need a review, states of matter was page 4, and that was a long time ago. The speed depends on how close together the molecules are. So if it's going through, if the medium it's going through is a gas, then sure, it's going to go 770 miles an hour. That's pretty fast. If it's going through a liquid, if you look, the particles are closer together. It's going to go a lot faster. And a solid, the particles are going to go the fastest. Now, why do you think that happens? Well, if you look at your paper, you see the word density. Turns out, when particles in a gas are traveling to bounce into each other, a sound wave creates a vibration and they have to bounce into each other, they lose a lot of energy finding their neighbor because they have to travel a much longer distance. So something that's higher density, like this liquid, the particles might bounce against their neighbors really easily and not lose any energy. That sound wave would go faster, it would go further, it would be heard easily. But the solid here, the particles don't have to go very far at all. They bounce against each other easily. They pass the sound wave without losing any energy. Well, losing a small amount, and it'll go even further. You can actually test it out yourself in here right now. Before we do, reminder, please do this in a way that won't bother other people. Don't be annoying while you do this. So, you're going to be pausing every now and then to do this. So, first of all, pause the video, take your headphones off, and tap on the table gently with your finger. Go ahead and do that. So did number 2, listen to how quiet that sound is. If you did it correctly, you probably made a sound that was so quiet that people around you didn't really hear it very well. So this time, when you pause the video, you're going to put your ear on the table and tap your finger again the same way. Go ahead and do that now. If you did it, then you would have noticed that the sound, even though you tapped your finger the same way and made the same sound wave, it sounded a lot different when you listened through the table. Now, we've got a couple experiments after the break that are going to show all of this in a different way. But today, what we want to do is we want to remind ourselves the big takeaway is that sound waves can go through all kinds of different matter. It can go through gas, it can go through liquid, it can go through solid. But it turns out that solids are the best conductors for sound. And gases, while they do make sound waves travel, they're the kind of the worst medium for sound. So today, you want to know the word medium, and you want to know which medium is the best, solid, liquid, or gas. All right, guys. I know you guys have a few questions because there are